Hello students, this is Fazal Wahab. In today's class is the continuation of the previous class in which we are going to find out the relative maximum and minimum values of the function hai. And today we will solve the question number 6, which is f of x is equal to e ki x sin x, and we have to find out the first derivative first, and then we will put the derivative equal to the derivative of this function, which is f derivative of x will equal to 0, and to find out the value of x, and then we will put those values of x for to find out the whether the function has a maximum or minimum value, and then we will find the values of the maximum and minimum values. Let's do that. F solution is dy over dx or f derivative. Differentiate f of x or y with respect to x. So f derivative of x is equal to e ki x sin d over dx of d over dx of e ki x sin x. Here we are applying the product rule here because ex and sin x are multiplying with each other. So e ki x multiplied by sin x, these are multiplying with each other. We will use the product rule. And what is the product rule? Okay, look at this. Here is, let's say, d over dx of u multiplied by v. You got two values, u and multiplied by v, and these are multiplying u and we are multiplying with each other. So what will be the derivative of this one? This will become equal to u d over dx of v plus v d over dx of u. This is the product rule. U d over dx of v plus v d over dx of u. This is the product rule. The same rules we are applying here. So e ki x d over dx of sin x plus sin x d over dx of e ki x. This is the product rule we are applying here. Now e ki x and d over dx of sin x is cos x plus sin x, and d over dx of e ki x is the same e ki x. There is no derivative of e ki x. The derivative of e ki x is e ki x. So here e ki x is common in both of them. E ki x is here, e ki x is here. So we are taking e ki x is common. So we got cos x plus sin x. This is the first derivative of this function. So first derivative of this function is f of x is e ki x cos x plus sin x. Now to find out the value of x for the maximum or minimum points, because here is cos x and sin x, we need to find out the value of x for f derivative of x. We will put the f derivative of x is equal to 0 for at stationary point. Look, let me write this one. At stationary points the f derivative of x or dy over dx is equal to 0. So put dy over dx is equal to 0. So e ki x multiplied by cos x plus sin x, make it equal to 0. Now e ki x is equal to 0. Here is e ki x is equal to 0. So now we will solve for x here. Take ln of both sides. Take ln log on both sides. So ln e ki x is equal to ln 0. So ln e key x is equal to ln 0, and now x will become x ln e x. This is the exponent that will become the coefficient. So x ln e is equal to 0, ln e is equal to 1, so x is equal to, now ln 0 is equal to infinity. Ln 0 is equal to infinity and ln e is equal to 1, so x multiplied by 1, you can write like this one, is equal to infinity, so x is equal to infinity. Number first value is this one. For the second value, e key x cos x plus sin x, cos x plus sin x is equal to 0. Now sin x is equal to minus cos x. Now sin x we can do like this one. Sin x is equal to cos x multiplied by minus 1. We can write like this one. This is the same. Both are the same. Now sin x upon cos x. This is multiplying here with the minus 1. So we will shift this to the left side. This will become divide on with sin x. So sin x divided by cos x is equal to minus 1. Now sin x upon cos x is tan x. Tan x is equal to minus 1. X is equal to tan inverse minus 1. X tan inverse minus 1 is equal to minus pi upon 4. You can write minus pi upon 4 means, or we can write like this one, 362 pi minus 2 pi, okay, minus pi upon 4. Pi upon 4, one value, because minus pi upon 4, the x for the tangent which is equal to minus 1, tangent is negative in two quadrants. In the second quadrant it has a negative value, in the fourth quadrant it has a negative value. So we will have two values for tan inverse minus 1. We will have two values. One in the second quadrant is 45 degree and the second is 45 degree in the fourth quadrant. In the second quadrant, 45 degree will become x1 is equal to pi minus pi upon 4. One is this one. And the x2 will become 2 pi. It has been already written here. Okay. 2 pi minus pi upon 4. Minus pi upon 4. Now here is 3 pi. It will become, look at this, 4 pi minus pi divided by 4. That will become 3 upon 4 pi. And here it is, okay, x2 will become 4 to the 8 pi. 8 pi minus pi upon 4. So x2, 8 pi minus pi is 7 pi upon 4. 7 upon 4, 5. So we got two values of x for the tan inverse x, which is 3 upon 4 pi, and x2 is equal to 7 pi upon 4. Now we will find out whether the function e key x sin x has a maximum or minimum value at x is equal to 1, which is 3 upon 4 pi, and also the function e key x sin x has a maximum or minimum value at x is equal to 2, which is 7 upon 4 pi. So we need to find out this one. So for this test, we need to find the second derivative of the function f derivative of f of x is equal to e key x sin x. So we need to find a second derivative of x. Okay, to check for, we need to write this one, to check for maximum or minimum points. We need to find out second derivative. Second derivative of x is equal to e key x into cos x plus sin x. Okay. Now these two are multiplying with each other again. E key x is multiplying with the cos x plus sin x. We will again use the product rule. So e key x d over dx of cos x plus sin x. So e key x, and then plus, we don't have the space here, so we will write this, cos x plus sin x multiplied by d over dx of e key x. So e key x is e key x, cos x will become minus sin x, and sin x will become cos x. This is the derivative of cos x plus sin x, okay? The derivative of cos x minus sin x and the derivative of sin x is cos x. Plus cos x, okay, plus cos x plus sin x, and derivative of e key x is e key x. So there is no change in this derivative of e key x because the derivative of e key x is e key x. So this is the derivative of e key x, which is e key x. Now we can take e key x is common in both of them. E key x should take common, is common. So minus sin x plus cos x and plus cos x plus sin x. Okay, minus sin x and plus sin x is cancelled with each other because both have the opposite signs. Therefore, e key x and cos x plus cos x is 2 cos x. Okay, these are multiplying with each other. So 2 cos x, or we can write this like 2 e key x cos x. This is the second derivative of the function e key x sin x. I don't have the space here, so I have to remove this first part. This one. Okay. Now put the value of for maximum or minimum points, put x is equal to 3 upon 4 pi and x is equal to 7 upon 4 pi in the function f of x. So f of 3 upon 4 pi is equal to e key 3 upon 4 pi and multiplied by sin key 3 upon 4 pi. Okay, now we can find out this value here. Okay, this is equal to minus 14.97, minus 14.97. So it is less than 0. Therefore, this function has a maximum value at x is equal to 3 upon 4, 5. Therefore, this function Yeah, therefore f of x, you can write this like this one, f of x has maximum value at x is equal to 3 upon 4 pi. Okay, for the second value, I think we do need to find out to subtract this 2 pi upon 4. So this is equal to minus pi upon 4. I think no need for this one, for this one. So x1 is equal to 3 upon 4 pi, and x2 is equal to minus pi upon 4 pi, pi upon 4. We don't need to subtract this from 2 pi. So for, okay, now put the value of x is equal to minus pi upon 4 in the function. F of minus pi upon 4 is equal to e key, okay, is 2 multiplied by cos x. Cos, or x is minus pi upon 4 multiplied by e key minus pi upon 4. So now put these values and we will get the answer for this one. 2 multiplied by, okay, I'm doing it, 2 multiplied by cos minus pi upon 4. Cos minus pi upon 4 minus pi upon 4 multiplied by e key minus pi upon 4 minus pi upon 4, and we got this value as 0.643. 0, okay, I think 0.643, which is greater than 0. Therefore, f of x has minimum value at x is equal to minus pi upon 4. So now we have to find out the maximum and minimum values of this function by putting the value of x is equal to 3 upon 4 pi. In this function we will get the maximum value, and minus pi upon 4, in this function we will get the minimum value. Okay, so I am going to remove this part. I don't have the space, so now maximum value first. Maximum value, okay, f of 3 upon 4 pi is equal to e key 3 upon 4 pi multiplied by sine 3 upon 4 pi, and we will get this value, which is 3 upon 4 pi is 7.487. 7.487, this is the value. Okay, the maximum value of this one. So maximum of is 7.487, and the minimum value is f of minus pi upon 4 is equal to e key minus pi upon 4 multiplied by sine minus pi upon 4. Now e key minus pi upon 4 multiplied by sine pi upon 4, we will put these values in this one, and we will get minus 0.3 to 1. So this one is the maximum value and this one is the minimum value which we needed to find this one, and this is the final solution of the question.